Welcome. We're going to answer this question before us. Let's give it a read. In a particular school, 55% of students are male and 45% are female. Of the male students, 13% say mathematics is their favorite subject, while of the female students, 18 prefer mathematics. Find the probability that, and then we've got all of these questions down here. So the question is, how are we going to answer them? What are we going to use to represent the probabilities here? Now, the question doesn't have to tell you. You need to be able to figure out what you're going to use here. And the best thing for you to use here is a tree diagram. So let's begin creating this tree diagram. So the first thing we have to encounter is whether or not we're going to select a male or a female. So we've got a male or a female, and that has to be our first step because this is going to impact what happens next, and that is whether or not they prefer maths. So the percentage for which they prefer maths, that's impacted by whether or not they're male or a female. So if we come here, we've got prefers or not prefers, prefers maths or does not prefer maths. And we have to do that as well. Once we've done that, we're now going to put in our percentages, so our probability for each one. So the probability that we're going to select a male is 55%, and we write that as 0.55. The probability that we're going to select a female is 0.45. Of the male students, 13% say that mathematics is their favorite subject. So that means 0.13 prefer maths. And this is very important. Do you see how it says of the male students? That's extremely important. That means of the male students, 0.13 prefer maths. Of the male students. And of course, we know that these need to add up to 1. So this is going to have to be 0.87. And then we continue. Of the female students, 18% prefer maths, 0.18. Which means down here will be 0.82. Amazing. Now, from the previous part, we know that if we multiply across a branch, we are going to find, in this case, the probability of M intersection of P, because this is our multiplication rule tells us that. We're multiplying these, and that gives us this right here. So this is going to be 0.55 times 0.13 is equal to 0.0715. This one, so I'm multiplying across this way now, it's going to be the probability of M intersection of P complement is equal to 0.55 times 0.87. So our answer is going to be 0.4785. Then we keep on going. Now we're going to multiply this way. The probability of F intersection of P is going to be 0.45 times 0.18 is equal to 0.081. We continue. Now we're going to go this way. The probability of F intersection of P complement is going to be 0.45 times 0.82 is equal to 0.369. Amazing. Okay, so we've got all of those. Now, let's see if we can answer some questions here. Find the probability a student prefers mathematics given they are a female. Oof, you need to look at that word given there. That word given is very important. So the probability that they prefer maths given they are a female. So it's given that they're a female. Now, this is where it's really important that you understand what our tree diagram is telling us here. Because all of these probabilities here are given conditional probabilities, aren't they? They're conditional probabilities. This one here is telling me the probability that someone prefers maths given they are a male. Because we've already determined that they're a male. So this is already assumed. It's already done. It's in the past. Now we want to figure out if they prefer maths. So this is whether they prefer maths given they are a male. So that means if I'm after the probability that they prefer maths given that they are a female, that's just going to be 0.18. So actually, no maths required here. It just requires you to understand what your tree diagram is telling you and understand what it means for something to be conditional probability. Because of the female students, 18 prefer maths. So that means a student prefers maths given they're female is 0.18. Okay, I think that's a really important one and that you kind of get your head around that. We continue. The probability that a student selected is female and does not prefer mathematics. So no conditional probability here. What we're just considering is the probability that a selected student is female and does not prefer maths. So it's they're female intersection, they don't prefer maths. We've figured this out. That is that one right there. F intersection of P dash 0.369. Amazing. Okay, we keep on going here. The overall percentage of students who prefer mathematics. This is using our law of total probability. So my law of total probability tells me if I want to find the amount of people that prefer maths, what I'm going to do is I'm going to add together the males intersection prefer maths plus the probability of the females intersection prefer maths. That's what I'm going to do. So I'll come up here and I'll find those numbers. M intersection of P is 0.015. 0.0715 rather, plus the probability of F intersect P is 0.081. 0.081. And when I add those together, I get 0.1525. And that is going to be my answer. So we're using our law of total probability there. And now we come to our lucky last. It says, given conditional probability that a student does not prefer maths, what's the probability they are male? Okay, we need to be careful here. The probability, now it's given they don't prefer maths. You have to get the order correct there. It's given they don't prefer maths. What's the probability that they are male? So it's in this order here. Write down what the rule is for conditional probability. This means I'm dealing with this. I know what my numerator is going to be because I can just come up here and find that. That's going to be 0.4785. So let's write that down. Let's come down here. 0.4785. Then how can I figure out what the probability of people that don't prefer maths? There are two ways I could do this. I could use my law of total probability here. I think that would actually be a silly way to do it because we already know the overall percentage of people who prefer maths. So those who don't prefer maths would simply be 1 minus 0.1525. And when we do that, we're going to end up with 0.8474. 0.8475 rather. Or the other way we could do this, and this is the longer way, which I wouldn't recommend, is we could just say, all right, this is simply going to be using our law of total probability, the males that don't prefer maths, plus the females that don't prefer maths. And when we add those together, we would get the same thing. We would get 0.8475. So sure enough, if you were to come up here, and let me just grab my calculator. If we were to add this one together, so 0.369 plus this one and this one, 0.4785, we would get 0.8475. 8475. So these numbers, they look very similar, but the numbers are rearranged. But yes, that is correct. Okie dokes. So that means down here, we're going to get 0.8475. Look at those numbers. All the numbers are the same. They're just rearranged. That's okay. I'm just freaking out here a little bit. That's right. So we're going to get 0.565. And we're all good. What a nice little question that is. Hopefully you enjoyed it and find using your law of total probability manageable and just know how to operate things like this. Hopefully you found this useful.